Small cells are the answer to dramatic mobile traffic growth, but new challenges in the backhaul accompany them. Learn how performance assurance solutions, right-sized to fit the demanding business model small cells imply, can accelerate deployment, assure and optimize performance in the highly dynamic world of HetNets and self-organizing networks. It's no doubt we are attached to our mobile devices to the point where they now outnumber us globally, populating the Earth faster than we are. Mobile data will increase 1,000-fold between 2014 and 2020, with users expecting service quality to keep in step. RF capacity has its limits, unable to keep up with demand unless a new radio access model emerges. Small cells allow operators to spatially share their precious spectrum, operating small cells inside the macro cell footprint, and effectively bringing the network closer to the majority of users, indoors and in highly dense urban areas. Unlicensed spectrum, including Wi-Fi, also relieves licensed band saturation, and small cells typically employ multiple technologies to scale their capacity. The solution is as effective as it is necessary. Mobile operators will deploy 5 million small cells annually by 2017, where over half the mobile traffic will be carried by more than 62 million small cells worldwide. Heterogeneous mobile networks, or HetNets, is the combination of many types of small cells that are used to provide right-sized coverage from the home, enterprise, and metro area to remote locations underserved by macro cells today. With coverage and increased access speeds comes revenue, largely driven by enterprise and high-traffic public areas, where mobile utilization is on the rise. Indoor femtocells, a common practice, will see slower growth as neighborhood picocells find wider deployment. It's clear how small cells increase QoS, or quality of service. Customer retention and utilization is improved. Just think of a time when you didn't have enough signal to continue a call or to load a video, and you've seen how small cells can make your experience significantly better and make the operator shine. It's a key differentiator as well as a necessity, so accelerating time to market is crucial. Offloading large amounts of mobile traffic is the key when it comes to backhaul. Up to 80% can be offloaded during peak usage periods, more than doubling macro cell and backhaul capacity. Macro cells need to retain capacity for mobile users in transit to minimize handoffs and to serve areas where small cells aren't installed. Backhaul moves to mesh topologies with LTE and the proliferation of small cells. The Enhanced Packet Core, or EPC, moves backhaul to layer 3 and introduces intercell communication to more efficiently handle data and signaling traffic. Simple hub-and-spoke backhaul models won't keep up with latency requirements, with a longer backhaul chain reaching further out to the service edge and more frequent roaming between cells covering ever smaller areas. Offloading to small cells also means offloading to new backhaul networks, either extensions of the macro backhaul or new ways of reaching the small cell altogether. A diverse range of technologies are being put to use to meet cost objectives and coverage, including licensed and unlicensed point-to-point radios, point-to-multipoint microwave links, fiber to the node, DSL and DOCSIS, and even customer-owned LANs and internet connections. New business models are also emerging: small cells as a service, and host-neutral distributed antenna systems, or DAS, can increase revenue for alternate access vendors and fixed-line ISPs traditionally providing last-mile backhaul access to mobile operators. All of these new backhaul technologies are required to meet the growing demand for data-hungry services. They also introduce new challenges to maintaining the quality of service required to provide a seamless user experience. Small cells come with significantly different deployment challenges than macro cells, but require the same or tighter performance. The added backhaul transport and processing latency introduced by further hops to user equipment can easily exceed allowable delays for cell timing sync, voice and control plane traffic if the backhaul is not carefully designed and monitored. With this tighter operating envelope comes the sheer volume of small cells that must be deployed, and the fractional contribution each makes to revenue. Installation, configuration, service activation, and optimization need to be nearly zero touch, need to be done right the first time. CapEx and OpEx pressures on small cells demand it. It's not just longer backhaul chains that threaten the quality of service of small cells. The very nature of installing a small cell within the coverage of macro lead to a variety of dynamics based on shared resources. shared spectrum, shared backhaul, shared infrastructure in the case of multi-vendor installations, and cells fending off interference in unlicensed public Wi-Fi bands. Let's not forget interference from the macro cells themselves, a common issue when transmission from two cells terminate on closely located handsets. Backhaul utilization is also highly dynamic, not just by time of day, week, or year, but also from user endpoints switching from a lower capacity carrier to a faster one in multi-band cells and roaming between cells. Each transition can create a step in bandwidth demand at any one location, compounded by bursting traffic as TCP negotiates increased transmission rates in backhaul networks with varying capacity and utilization. Quality of service is also threatened by frequent handoffs between neighboring small cells or from small cell to macro, even potential ping-pong scenarios. User endpoints in transit through a cell field, for example from a train or elevator in an office tower, can generate significant signaling messages as handoffs are negotiated intercell over the X2 interface or by the mobility management entity at the mobile switching center. As networks move closer to the users and backhaul fans out deeper to support more endpoints, and 15 small cells per macro is typical, operators lose the performance monitoring visibility they rely on to support macro cell quality of service and ultimately the customer experience. Backhaul performance is comparably reliable in the fiber-rich and licensed backhaul connections feeding macro sites. The wide range of alternate access methods, from inexpensive RF to copper and even customer internet connection backhauling methods, is accompanied by variability in latency, capacity, stability, and reliability. Small cells, and LTE in general, are also dynamic by design. From self-optimizing networks of cells that can tilt antennas, adjust power transmission and receiver gain, or even hibernate in sleep mode to conserve power during times of low utilization, the network is alive, constantly adjusting to optimize its own performance. This should be a good thing, but considering standards for self-organizing networks, or SON, are only now emerging, and each vendor has a different approach to optimization, this can be more of a problem than a solution. Multi-vendor SON interoperability is years away if it will ever be achieved. Multi-vendor overlay solutions may be the answer. However, these methods will require performance data from the multi-vendor, multi-technology backhaul to be effective, a challenge in itself. Like in SON, interoperability concerns also arise in the backhaul. Carrying traffic from small cells, not necessarily carrier-grade devices, through other network elements and technologies can affect end-to-end preservation of multiple service data flow tiers, critical to ensuring bandwidth is properly allocated to signaling and real-time traffic before filling the backhaul with general data flows. With small cells contributing to a highly dynamic environment, it's clear that real-time backhaul performance monitoring is required to maintain visibility and quality of service. There are too many moving parts in these networks to leave performance to chance. In addition to low-touch deployment requirements, the low cost of small cells constrains the technology choices for assuring their performance. Traditionally, macro cell backhaul is monitored by network interface devices, or NIDs. Exedian Networks units now monitor over 100,000 cell sites in the US alone. These devices, which can also be used to condition traffic, terminate Ethernet services, and more, are the perfect complement to 3G and 4G macro base stations. Small cells have different performance monitoring needs. Their footprint, power, and cost also need to be very small, without sacrificing the ability to precisely measure critical KPIs such as latency, delay, utilization, packet loss, and availability. The introduction of smart SFPs, pluggable modules with integrated flow performance assurance processors, and similarly low-cost gigabit Ethernet modules for copper connections address the requirements of both indoor and outdoor small cells. From the enterprise cells connected to gigabit Ethernet LAN switches and small cell gateways, to micro and pico cells on lampposts fed by PONs, DOCSIS, RF, or DSL access links. Testing methods need to support the all-IP layer backhaul of the Evolved Packet Core. The Y1731 OEM standard, widely used to monitor the quality of service of Ethernet backhaul to macro sites, can't span IP domains. The Layer 3 Two-Way Active Measurement Protocol, or TWAMP, can be used to achieve a similar result where the standard is supported. The luxury of over-provisioning backhaul bandwidth to assure quality of service is impractical in 4G networks, where traffic demands and spectrum constraints clash, and bursts of TCP traffic can easily result in high packet loss in the backhaul during peak periods. 3GPP addresses this constraint with the standardization of multi-tiered service data flows, or SDFs, governed by quality class indicators and the concept of end-to-end bearers for each type of flow. A typical LTE deployment would implement at least 3 SDF classes, for signaling, for real-time traffic, and for everything else. Each tier needs to be monitored independently to ensure quality of service is maintained under real-world conditions. Tiered SDFs are not only critical to maintain network performance, but also to allow operators to increase revenue by tiering quality of service by type of customer, and to introduce new services and applications. With streaming video and the emergence of LTE broadcast video, the asymmetrical nature of uplink-downlink bandwidth will remain significant. The clear implication is that quality of service monitoring must be directional. It's common that phone calls, as an example, are clear from one caller's perspective, but unusable at the other end. We've seen how rapidly small cells will be deployed, and how their business model requires an efficient yet precise approach to performance assurance. HetNets are highly dynamic, adding to performance-affecting challenges inherent in the shift to multi-tier Layer 3 backhaul that goes beyond hub-and-spoke topologies to directly interconnected cells. Establishing and maintaining performance in small cell backhaul networks means addressing the full service lifecycle. Service activation must be validated and benchmarked, quality of service must be monitored from core to cell, as well as intercell, and ongoing performance optimization must have access to current performance data from all corners and layers of the network. The fundamental requirements to any such solution will include standards-based test methods to ensure interoperability with the greatest range of networking and test platforms, and to take advantage of performance monitoring functionality already available in many network elements. Ubiquitous coverage, from the MSC to macro and small cells, from layers 1 to 4. The ability to conduct one-way measurements, because round-trip measurements are not sufficient in highly asymmetrical networks. One-way delay measurements are critical to verify PTP timing and sync when running lte-tdd network protocols. High accuracy and precision are required. When a performance requirements for latency are a handful of milliseconds, performance assurance solutions need microsecond-level resolution for results to be meaningful. Granular performance visibility. Microbursts and quickly shifting traffic trends mean sub-second measurement frequency can make the difference between detecting issues or missing them between samples. Measurements must be continuous, and real-time results need to be reported, providing immediate feedback for network optimization and proactive quality of service degradation mitigation. Finally, all solution components must be structured within an open, programmable architecture that can integrate with existing and emerging network management, SON, SDN, and other platforms, as well as support feature upgrades as new standards and test methods emerge. Automated service activation testing is the first step towards establishing a performance-assured backhaul network. Standards-based Y1564 at Layer 3 and RFC 2544 at Layer 2 are the trusted turn-up standard approaches used to establish a performance baseline and activation birth certificate. To be useful in small cell deployments, these tests must be conducted between neighboring cells as well as to centralize resources at the MSC and at base station hotels, where Cloud RAN may be hosted. Tests need to be conducted to every service delivery endpoint, and small cells are an ideal candidate for pluggable smart SFPs, like the Xedian Nano module, which can maintain performance monitoring streams in addition to generating full line rate multi-flow traffic for turn-up tests and on-demand troubleshooting. The pluggable form factor is ideal, not only because of its attractive cost, but also because of minimal power and zero footprint attributes. To ensure small cells can be deployed by untrained technicians, or even by the customer themselves in the case of enterprise femtocells, the service activation process needs to be supported by workflow automation. With Xedian Network's Vision EMS platform, turn-up testing sequences can be triggered by the discovery of a new small cell coming online, with results centrally stored and subject to test templates and acceptance criteria specific to the location, type of cell, or application. With test traffic generated from the site itself, tests can be conducted immediately upon install, without the congestion concerns that come with large-scale centralized test heads. Distributed traffic generation also permits site-to-multi-site concurrent testing, including intercell performance validation. With a capable northbound interface and API, test results are openly available to NMS and third-party performance platforms. Xedian provides this capability through its Skylight interface, used by the SEV1 performance reporting platform at leading operators, for example. The NGMN Alliance considers delay variation, packet loss, and availability as the key backhaul quality of service KPIs for small cell monitoring. The combination of ITU-T's Y1731 at Layer 2 and TWAMP, which is RFC 5357 at Layer 3, are their suggested methods because of the wide deployment of these industry standards in elements ranging from core routers to macro base stations and a growing number of small cells. The Exedian VNID platform can conduct thousands of concurrent performance monitoring sessions to diverse endpoints at the service edge and at key locations along the service delivery path, to network performance elements such as Exedian's GX unit, to small SFPs and copper gigabit Ethernet modules like the Nano and ANT modules, to TWAMP and Y1731 reflectors in network elements and small cells, and to software agents that can be embedded into nodes, virtual machines in data centers, and even handsets. In addition to the metrics these standards support, bandwidth utilization by port and service data flow are key to capacity management and planning. Port-level utilization is required in addition to the utilization of each service flow, as up to 30% of total backhaul traffic is overhead, above and beyond the service data. As an example, IPsec overhead consumes an additional 14% bandwidth. Signaling can total up to 4%, and 10% more can be attributed to transport protocols. With so many service endpoints and flows, relying on simple thresholds for fault detection and management can result in a sea of red on NMS and fault management dashboards. Actionable, compound metrics based on derived performance statistics can cut through the noise and provide insightful alerts to operators. Using statistics calculated on the fly as measurements are conducted, the VNID platforms provide percentile-based fault mediation, allowing meaningful alerts to be triggered using compound criteria. For example, provide a warning when one-way latency over the signaling SDF is higher than 5 milliseconds 95% of the time. The combination results in total network coverage, both end-to-end, intercell, and segmented along traffic paths. Over 50 real-time metrics and statistics, the Network State Plus, are available continuously for fault management, reporting, quality of service visualization, and performance optimization both from Exedian platforms and third-party NMS systems and SDN applications via the Skylight API. Running the most efficient backhaul is good economic sense, as well as a foundation for exceptional quality of service that only the best use of all resources can provide. Microwave backhaul links can vary in capacity with changing weather, seasonal temperature swings, interference and multipath, and countless other factors. Running a blind backhaul, where data is pushed downlink when capacity is not available to carry it, can result in over 30% lost capacity due to packet loss and retransmission. Dynamic Performance Optimization, or DPO, is the insightful orchestration of link capacity awareness with real-time hierarchical QoS enforcement and traffic conditioning. Just like SON aims to optimize the performance of LTE macro and small cells, DPO can optimize distribution of backhaul bandwidth where it's needed, and groom data to fit links' current capacity. This results in a congestion-free, lossless RF backhaul, as retransmission of packets is pushed uplink where bandwidth is less scarce. Exedian solutions provide the real-time, per-second, network-wide quality of service KPIs needed by performance management systems and SDN or SON controllers implementing DPO. Real-time link capacity information is measured by network performance elements such as the GT, GX, or 10 gigabit Ethernet LT series, or small form factor units like the Nano and ANT modules, without any need to query or embed software on point-to-point radios. This per-link capacity information is combined with Network State Plus metrics to provide a complete, segmented, and per-flow view of current performance via the Skylight API to optimization systems or applications. Reflecting the immediate state of the network, per-flow hierarchical traffic shaping and conditioning policies can then be pushed to head-end and selected aggregation routers to control traffic as it distributes into the backhaul. The net benefit is drastically improved quality of service and lower bandwidth utilization from MSC to small cell, extended radio infrastructure lifespan, and maximized use of scarce spectrum. We are now seeing the impact small cells have on mobile network capacity, quality of service, and the ability for mobile network operators to scale with the 1,000-fold traffic growth expected over the next several years. As fast as they can be deployed, however, industry experts still expect 4G networks will reach their limits within 5 years. 5G networks and standards are the inevitable answer, taking bandwidth another order of magnitude forward, supporting 1000% device densification and the Internet of Things. 5G will come with a further tightening of performance requirements, approaching 1 millisecond latency bounds, tighter packet loss, and higher availability limits. Accidian's current solution portfolio is ready for the future. The required precision, granularity, and scale exist today, and the Skylight VCX network function virtualization platform introduces a new level of programmability and feature extension to nano and ANT modules. NFV means these cost-efficient units can extend into virtual CPEs, fully featured test heads with virtualized results, calculations, statistics, and reporting. It's clear small cells make a big difference, and are the next most important step in increasing capacity, coverage, and quality of service in mobile 3G, 4G, and the 5G networks of the future. And the future is close, with 62 million small cells expected to carry half of mobile traffic by 2016. Despite the need to keep CapEx and OpEx within strict limits imposed by the small cell business case, backhaul performance will need to meet new levels of precision. All this in a HetNet that's more dynamic, diverse, and interactive than traditional macrocell backhaul. Without performance assurance solutions as flexible as the HetNets themselves, operators will lose quality of service visibility as endpoints rapidly increase in numbers and move closer to the customer. Automation is required to ensure complete service assurance is conducted in a uniform, near zero-touch manner over the full service lifecycle, from service activation testing to ongoing monitoring and dynamic performance optimization. By deploying a standards-based, ubiquitous, real-time, open, and programmable performance assurance solution, service providers are in the position to drive the growth of their network and their revenue base with their eyes wide open. Thank you for joining me for this introduction to small cell backhaul performance assurance challenges and solutions. You can learn more from our team of performance assurance specialists. Contact us at Accidian.com to discuss your particular small cell applications.